So if I'm jumping into this first example, I'm going to treat my numbers just the same way we talked about on Friday. The cubed root of 8. What's the biggest perfect cube that goes into 8 evenly? No, 2 is not a perfect. Oh, you guys are kind of already telling me what the cubed root of 8 is. 8 already is a perfect cube, yes? So we don't need to break it down into 2 separate parts. So I'm just going to leave it as the cubed root of 8 for now. Yes, I will eventually change that to a 2. But hold on. Now, with x to the 4th, is 4 divisible by 3? No, so I do have to break this one down. What's the closest exponent to 4 that is divisible by 3? 3. So I'm going to break down x to the 4th into x to the 3rd times x. Y squared, is that divisible by 3? No. And I actually can't break this one down because there's no number underneath 2 that is divisible by 3. So unfortunately, that's just going to stay put. And I'm not going to be able to do anything with that. And then z to the 8th power, is 8 divisible by 3? No. What's the first exponent less than it that is divisible by 3? 6. So I'm going to break this up into cubed root of z to the 6th times the cubed root of z to the what? 2nd. See, now I'm using exponent rules. I don't want to take that too much for granted. I'm using exponent rules to replace z to the 8th with z to the 6th times z to the 2nd. I just wrote 8. Okay? Z to the 6th times z to the 2nd replaces z to the 8th, but I broke it up that way because I do know the cubed root of z to the 6th. And I do know the cubed root of x cubed, so I'm going to circle that. And I do know the cubed root of 8. So here we go. I'm going to now apply the cubed root sign to everything. I have my negative 2 out in front. What is the cubed root of 8? 2. What is the cubed root of x cubed? X, so that's accounted for, that's accounted for, that's accounted for. And what is the cubed root of z to the 6th? Z squared, because 6 divides by 3 twice. And then everything that's left that's uncircled and unaccounted for has to just be kind of smushed together underneath a final radical. The cubed root of x, y squared, z squared. And then the only thing I need to do is kind of clean up that coefficient in front. Negative 2 times 2 is just more efficiently written as negative 4, and then the rest is the same. Good? Any questions? Okay. Number 8. We're back to square roots. Okay? Obviously, you guys have realized that when it's a square root, they don't have to write the 2 there. The understanding is in math is if it's a square root, the root just tells you that. Any other root, you have to write the little number there. So we're just going to take this piece by piece. We're going to do the numerator separately than the denominator. Yes. So 40. Cameron, how am I going to break down 40? Root 4, root 10. Good. How am I going to keep going, Cameron? How am I going to break down x cubed? Very good. And y to the 9th, Cameron? Y to the 3rd and y to the 3rd would be y to the 6th. Here's what we're trying to do with variables. You're looking for the first number under 9 that will be divisible by 2. What is that? First number less than 8. So it's going to be y to the 8th times what? Right, perfect. So that's my numerator over. How am I going to break down 81? Trick question, Madeline. Am I going to make it 9 times 9? I could. I actually could. But why would you? Because 81 is already a perfect square. So it's a trick question because we're not going to break that down. We're just going to leave it as root 81. For now, we'll eventually make it 9. And Maggie, how would I break down z to the 7th? Very good. So in my numerator, I'm going to circle each thing that I can take the square root of, and same in the denominator. So, Nathan C. Nate, tell me what is my numerator going to look like? Take it slow. Perfect. That takes care of all those. Root what? Perfect. And what's my denominator going to look like? Grace. Perfect. Nice. How do we feel about that? Good? Okay. Now, we're going to start moving into operations a little bit. So that was all just straight simplifying. Single terms, simplifying. We're going to get into adding and subtracting today, multiplying tomorrow, dividing on Wednesday. Okay? Adding and subtracting, let me tell you this. You can only combine like terms. Right? You know that. In radicals, it's combining like radicals. And right now you have a radical 4x cubed and a radical 9x cubed. Are those like radicals? No, because what's underneath them is different. So you simplify first, and if they end up being like radicals, then you can combine them. If they don't, then you have to leave them separate. So on this first term, so unfortunately it's going to be like 2 simplifying problems in one. I've got the 3. Do I need to break down 4? No, so just leave it root 4 for a moment. Do I need to break down x cubed? Yes, into root x squared, root x. So I'm going to circle my 4, circle my x squared. The square root of 4 is 2. Can we do the 3 times 2 all in one step right now and just make that a 6? Square root of x squared is x, so 6x root x minus. Now I'm on to the second term. Do I need to break down 9? When I say break down, I mean, do I need to make it like 3 times 3 or anything like that? And the answer is no, because it's already a perfect square. Yes, I will simplify it in a minute. X cubed, again, is root x squared root x. So the square root of 9 is 3, and 6 times 3 is 18. Square root of x squared is x, and then root x. Now are they like radicals? Yes. 6x's of these things and minus 18x's. What's 6x minus 18x? Negative 12x root x. We've combined like terms. Okay? Any questions on that? John? So like, why didn't I just subtract them to begin with? Because the radicals would have to be exactly the same in order for those to be combined. So if it was like 3 root 4x cubed minus 6 root 4x cubed, and they were both 4x cubes, I could combine them right away and say negative 3 root 4x cubes. I could do that. And then I would still have to simplify my final answer. So if they were already like terms, go ahead and combine them. But they were not. So usually you simplify first, and then, oh, look at that. They are all of a sudden they're like terms, and so then we can combine them. Good question. Okay? On this next one, are any of them like terms already? Like radicals? No. So we're going to break this first one up. 3 can't be broken down. x cubed is going to be x squared times x. So then I'm going to circle the square root of x squared because that is x, and then root 3x is stuck. So there's my first term simplified. Moving to my second term. I have the 4x. How do I break down root 12? What times what? Root 4, root 3. And then root x I'm not breaking down. And the square root of 4 is 2 times the 4 that's already there gives you 8. So 8x, 4 times 2 is the 8. You've got your x there. And then root 3x. And then how do I break down 27? 9 and 3. Good, Cameron. Root 9, root 3. That x is supposed to be under the radical as well, so root x. So the square root of 9 is 3 times the 2 that's already there is negative, you have the minus 6x, and then root 3x. And so sometimes you'll get two that are like terms and the third that is not, so you'd only be able to combine the two, but here all three of them are like terms. So what is 1x plus 8x minus 6x? Right, 1x plus 8x is 9x, 9x minus 6x is 3x, and then radical 3x. Does that make sense? So let me just give you a quick side note. Sometimes you'll end up with like this. Where two of the terms are root 3x's. So these two I can combine. 5 and 1 would make 6 root 3x's. And then this is just going to be by itself. So your answer ends up being a binomial because not all the terms are combinable. Yes? So just be aware of that. Okay. Cubed roots. What's the biggest perfect cube that goes into 24? How can I break down 24? 8 and 3, cubed root of 8, cubed root of 3, minus, what's the biggest perfect cube that goes into 81? Yeah, 27 times 3. So what is the cubed root of 8? 2 times the 2 that's already there is going to make that 4 cubed root 3. And the cubed root of 27 is 3 times the 2 that's already there will be minus 6 cubed root 3. And 4 of these things minus 6 of these things is how many total? Negative 2 of these cubed roots of 3. Good? We're actually not going to do that last question, but I have a curious question for you here. Just look at this. You don't need to write it down. But if I'm taking the nth root, now this is a little weird because n is obviously a variable and not a number, but can you take the nth root of 3? No. So I'm just going to break it up into the nth root of 3 times the nth root of 2 to the nth power. What's that going to end up being? Just 2, right? The nth root of x to the 2n power. Remember when we're dealing with exponents, we see if this is divisible by that. Is that divisible by that? Yes. So that's going to be able to be reduced. So this is going to be the nth root of 3. You guys just told me that will be 2. This will be x squared. Very good, because this 2n divided by n is 2. And is n plus 3 divisible by n? Probably not. We don't really know because we don't know what n is, but we'd have to break that up into y to the nth times y to the third. Does that make sense? Because exponent rules say you would add those. So this one, what's the nth root of y to the nth? y, and then you'd be left with the nth root of y cubed. So your final answer would be these things out in front, 2x squared y, nth root of 3y cubed. Yes? Kind of makes you think at a totally different level. So your homework is to finish the same worksheet. The answers are the ones did I send them out, or did I only send out the half on Friday? I'll have to go back and check. If I haven't already sent the answers, I will. If you need a worksheet because we're not here on Friday, come grab that.